Hello, this is Dr. Liu, and I'm going to show you how to do the standing wave lab. So here I have a string. It's really difficult to see there's actually a string. Even if I have this piece of paper right behind it, the video may not have high enough resolution to show a black string. So what I have here on this end is a vibrator that vibrates at 120 hertz. And this end, I have a pulley. So a string is dripped over the pulley. And at this end of the pulley, I have a hanger. Let's take it out. So I have a hanger with some mass on it. Let's see how much mass it reads. The hanger is 50 grams, and I have another 50 grams and a 5, so 105 grams altogether. That depends on the length of the string. So let's put this back and make sure it doesn't swing. And if you're close enough, you can actually see there are uh, locations where you can see the string more or less not moving at all. But then also the rest of the locations you have these peak and valleys of the string. Um, it may be even better if you try to do this way. I may not actually show in this video, but if you're here, you'll be able to see that. So this is a standing wave. And if I start counting how many of these troves or peaks are there, so there's a total of seven at the moment. So there's one, two, three, four, five, six, seven. Actually, there's eight. Okay, there's eight. Corrections. There are eight of them, and the amount of tension required is provided by 105 grams of weight. So if I start adding more weight, the this standing wave will disappear, but it will be replaced soon enough by seven of these peaks and troughs, and then six of them, five, four, three, and a two. If I just keep adding more masses, and I need to be accurate down to about 1 gram or 2 grams, and we should not attempt to do a one peak and the trough that is like a jump rope shape because that would require more weight than the whole system can hold. So the maximum, the minimum amount of this half wavelength is two. So if you see two of them, that is great. So that's the maximum, and you should stop. Um, so let me pause the video. I'll get something that's a little easier to show. Okay, so we're back at the setup. And now a closer look. This has actually six half waves because I added some more weights. And as you can see, there is this, uh, peak and a trough, and that's right here. And this is a point that doesn't move. So if I approach with a piece of paper, you can hear this. Yeah, this hitting the trough. What if I just hit the non-moving part? Yeah, there's not much sound at all. I'm actually pushing it against it, but that's not much sound because there's no motion. Here's a lot of motion. So in order to get exact, what you need to do is you need to add weights to the end very gradually. So to this end, and once you think you're getting close, you can just put your finger on top of a weight, just tap on it very gently, see if the shape will improve. That means widen. That is basically getting closer to the weight, and then you can add a small amount of weight and do the same thing. Press your finger down on the weight very gently, and then you'll be able to see if this pattern widens or narrows. If it narrows, that means that you have had a bit too much weight. Try to reduce a couple of grams. And I also have brought a meter stick, 2 meter stick, and this needs two people to do it more carefully. And what this needs to be done is you need to measure the total length of the string. One person can hold it at the end where the vibrator is, and then the other person holds at the other end. and just measure the total length of string. So that is a required measurement for this lab. So let's pause and we'll see if we can get an even bigger feature with more weights. Okay, so now we have only three of these half waves. And as you can see, this is actually bigger than what we had before. And it's probably going to buzz even stronger. Yeah, more strongly. And I can also approach the non-moving part. Almost no sound. Okay, so this is a little over 700 grams. So the next one will be the last one with two of these half waves, because only one half wave that's beyond the weight limit of our system. Okay, so this is the last part of the experiment. We have two half waves, and you can probably hear the sound is louder also, and the vibration has a larger separation, and we have over a kilogram of weight on that end. So you can imagine if we go to only one half wave, it would be too heavy for the system. So now I'll just count the weights and conclude the experiment. Thanks.